The last two transformations that we're going to look at, numbers 9 and 10, deal with reflections. And the two different type of reflections that we will be looking at are reflections over the x-axis and reflections over the y-axis. So notice that both of those with the reflections both involve negative numbers or a negative sign. That's one reason, or that is in fact the reason why all of the conditions in number 5, 6, 7, and 8 have the absolute value on them, because it didn't matter if the number was positive or negative. It was just the number that we saw that told us if it was going to be a stretch or a shrink, depending on if its absolute value is bigger than 1 or smaller than 1. If the number was negative in 5, 6, 7, or 8, the negative has to deal with being a reflection. So all negatives are reflections, and we'll see examples of distinguishing the negative from the number when we actually look at some examples. But to see what's going on with numbers 9 and 10, this time I'm going to look at the parent function, the square root of x. This graph looks like this. In number 9, we can see that there is a negative being multiplied to the outside of the function. So that looks like y is now equal to the negative square root of x. Let me move this. And now we can see what that new graph looks like. So let's go look at our table. And the first thing we'll say is, well, how did the equation change? Well, the equation changed by us multiplying outside of the function by a negative 1. And what I mean by outside is that the minus sign went outside the square root, not inside with the parentheses. That is on the outside. And we know that outside things happen vertically. We've already seen that pattern. And if we think about a vertical reflection, that would be a reflection over the x-axis. The graph flipped over the x-axis when we put that minus sign on the outside. And then to answer the last question of what's going on with the points, let's go look at some points that are on the original graph. Like for instance, the point 42 is on the original graph. Why do I not see that? Oh, because we're not zoomed out enough. The point 93 is on the original graph. So those are points that are on the regular square root of function. And then when we reflect the graph over the x-axis, the 0.42 flips down to 4, -2. The 0.93 flips down to 9, -3. So what's happening to the graph when we reflect over the x-axis, what's happening to those points is that we change the sign on the y coordinates. The x coordinates stayed the same, but because we flipped over the x-axis, the y values then change their sign. And I was intentional with, I intentionally did not make the y values negative, because sometimes they will start off negative and then they will flip up to become positive. So what is happening is that we're changing the sign on them. So now let's look at the other transformation. This transformation now has the negative on the inside of the square root. So first things first, for how the equation is changing, I'm going to write that we replaced x with negative x. That is how we got the second equation that we graphed. And then we'll talk about what do we see that happened to the graph to give us the new graph. Well, looking at the graph, we can see that this graph, the new graph, is now been reflected over the y-axis. The graph flipped backwards, which makes sense to us because this negative right here is happening on the inside of the function. And we know things that happen on the inside of the function happen horizontally. And if you think about a horizontal reflection, if you think about something flipping over the y-axis, that is going to be happening horizontally. And the last thing we'll look at is how are these points changing. So for instance, there's the 0.42 and 93 on the original graph. The points on the new reflected graph are going to be the points -42 and the points -93. So we can see that when we reflect a graph over the y-axis, how the points change is that we need to change the sign of the x coordinates. So that completes our transformation table. Before we go on to look at more examples, I want to talk briefly about what I meant with the negative always being a separate transformation. Let's say, for example, that we have y is equal to the square root of negative 3x. Let's talk about how many transformations we see in that. So there's a couple things happening. There is one, the 3 that we can see there. I erased part of my x. But one, there's the 3 that we can see there. And then the other thing that's happening is, let me fix this. Okay, so there's the 3, and the other thing that's happening is the negative sign. So two things are happening. There is a 3 that is on the inside of the function, and there's also a minus sign that's on the inside of the function. Some people, I can understand the impulse to look at this and just first see, oh, that's just a negative 3 in front. Well, even if you look at the entire negative 3 and you think of that as your A, and I'm now looking at between 7 and 8, as you see 7 and 8 have a number with the X on the inside. These conditions tell you that you need to look at the absolute value of that. So you would look at the absolute value of negative 3, which is a positive 3, which is bigger than 1, to say, okay, well, that is a horizontal compression. So it's a horizontal compression because 3 is bigger than 1. And remember, horizontal things happen backwards. But what you also have to do is realize that the negative itself is its own transformation. That is a negative on the inside of the function, which is what's happening in number 10. So one of the transformations is a horizontal compression. That's from the 3. And another transformation is a reflection over the y-axis. That's from the negative. So the whole point of that example was that if you see a negative number multiplied inside the function or being divided, you should think of the number itself, in this case the 3, as one transformation. It's either going to be a stretch or a shrink, horizontal or vertical, depending on if it were inside or outside. And you should think of the minus sign as a separate transformation that's either going to be a reflection over the x-axis or a reflection over the y-axis, depending on whether it was on the inside or on the outside of the function.